Good morning, good evening, good afternoon, ladies and gentlemen. This is Eisaku Toda of the Secretariat of the Minamata Convention again. Thank you for participating in this Minamata online session. We in the Secretariat, we started this online initiative quite recently from this autumn. The series of sessions consists of 3 streams. First one is this stream, which is we call what we call Mercury Science, and we co-organize the whole Mercury Science series with the ICMGP International Conference on Mercury as a global pollutant, and we co-organize some of the sessions with the UNEP Global Mercury Partnership. The second stream is about implementation. We call it implementation review and support. And this is to briefly provide a review of the convention requirements and the methods or any guidance on how best to implement these provisions. The third stream is about the preparation for the fourth conference of the parties that will be held next year. Please note that the participants are already automatically muted, so you will not be able to unmute yourself. We will try to convene an oral Q&A session at the end, but since the time is quite limited, we may not be able to do so. Your questions are welcome, and I think you will be able to activate the Q&A box and participant list box. If you have any questions, you can start putting questions even while listening to the presentations. I would like to express my sincere gratitude to all the panelists who kindly accepted to speak. I think I will introduce them as they start to speak. So I think this is it for the introduction. I think, yeah. I think this session is recorded, and the presentations, copy of the presentations will be made available on the website after the session. We are still, I think, waiting for one panelist, and I'd like to ask my colleague Tak to try to contact her in case she has any trouble connecting to the system. But since it is already 2:04 in Geneva, I think we can start. And I will start with the explanation or background of this session. If I can have the second slide, please. So one of the background is of the science session is the requirement for the effectiveness evaluation. The Minamata Convention requests the COP to periodically evaluate the effectiveness of the evaluation, and it says that the evaluation shall be conducted on the basis of available scientific, environmental, technical, financial, and economic information. So we would like to contribute to the process by convening the spreading of the scientific information and the exchange of scientific information. Especially the COP decision MC3/10 of that was made at the third meeting of the Conference of the Parties in November last year, the conference of parties requested the Secretariat to advance the work to prepare a report on for the effectiveness evaluation, which includes the report of mercury trade supply and demand report. That includes the aspect of mercury waste flows and stocks. Next slide, please. So the first three series of this science stream started 2 weeks ago with the mercury flow, supply, demand, and trade. And this is the second one, looking at the waste aspect. And the third one will be on emissions and releases to the environment, which will be 2 weeks from now. And also, this slide includes some information on the other streams. Next slide, please. This, I think, my colleague from UNEP, Sandra, will speak to this figure. This is taken from the UNEP work on from its report on mercury supply, demand, and trade. And the mercury flow, the major part of the supply and demand was dealt with in the session 2 weeks ago. But you can see the on the right-hand side, the second bubble, the long-term storage or environmental sound disposal, and at the bottom we have recycling, recovery and recycling. This flow relates to the waste flow that we are going to look at. If you can go to the next slide, I took this slide from the Japanese material flow study, not only because I'm from the Japanese origin, but also we note that this is one of the most comprehensive analysis, domestic analysis of the mercury flow. So I think this figure is too small for you to read, but it distinguishes the disposal in landfills and release to soil, the release to water, and the emission to air from incineration. And of course, we may it depends on the definition of the system, that boundary, but we may include the accumulation in society in this chart. So you would like to see, look at some different approaches taken in different countries, jurisdictions. The next one is my last slide. This is a conceptualization of the material balance. I took this from an OECD report on material resources, productivity, and the environment. And I think this is largely in line with the mercury flow analysis that we have seen in previous slides. But one thing to note is the last what was on the bottom, domestic extraction of domestic extraction and of unused material unused materials, and this what this means is that there are some challenges in considering how we handle the extraction of the primary mercury mining and byproduct mercury from mining if the remaining mercury is landfilled at the site where we are going to set the boundary. So we invited colleagues from the mining industry to look into this. We also invited the waste management expert, waste industry, but very unfortunately he was not able to make it, but he very kindly agreed to work, cooperate in follow-up work. So this is my very brief introduction to today's session, and as part of the openings, I would like to invite my colleague Sandra, who work in the United Nations Environment Program, servicing the UNEP Global Mercury Partnership. Sandra, floor is yours.
Thank you very much, Eisaku, and welcome everybody. Thank you for the invitation. I look forward to hearing the distinguished speaker and panelists today. I'll make this introduction very short. If we could go to the next slide, it's indeed showcasing reports that UNEP has developed on global mercury supply, trade, and demand. And that was a way to link to the previous science webinar that took place about 15 days ago, and focus the discussion on the lower part of the diagram, with identification of waste flow being an important source of mercury. Next slide is actually highlighting that after this and the global mercury waste assessment in 2017, so all this before the entry into force of the convention, UNEP continues to work with mercury monitoring on open burning of waste. And as my colleague Honda from IETC in Japan could not be with us today, here is a minute where you will be able to see him if the video works. I don't know if we can click on the link.
Sandra, I don't think it works, okay, because we do a PDF projection. Sorry about that.
Yeah, okay, no worries. So this is I'm happy to post the video on the chat after my brief introduction, and so you'll be able to see him after this this event. This is basically highlighting IETC's work on mercury monitoring of open burning of waste and open dumping site in collaboration with the Japanese Ministry of Environment. And we're looking forward to results from this monitoring soon. And the third part of this presentation is to highlight that UNEP, through Secretariat of the Global Mercury Partnership and its partnership area, are actually also contributing to this work on waste and related flows, and including on cross-cutting aspects. So this is to briefly highlight the Global Mercury Partnership as a voluntary multi-stakeholder network initiated in 2005 with the objective to protect human health and the environment from the release of mercury. And its current 3 priority focus: supporting the timely and effective implementation of Minamata Convention, providing knowledge and science on mercury, and delivering outreach and awareness raising towards global action. The next slide actually highlights the partnership areas, the 8 partnership areas of the Global Mercury Partnership. And so definitely supply and storage and waste management are 2 very important partnership areas for this topic. Certainly air transport and freight as well. So I'm very happy to see that Mrs. Asari will be speaking today, and she's the co-lead of the waste management partnership area of the Global Mercury Partnership. With that, I wish you a very good discussion, and thank you again for the invitation.
Thank you, Sandra. And in our experience, we learned that the best, the most stable way to share the screen is to the PDF. So we don't have a sophisticated way of showing videos and click on links and so on and so forth. So that's where we stand. So thank you very much. And then I would like to start the presentation sessions. We invited 5 speakers, and I will introduce them as they start to speak. The first speaker is Dr. Misuzu Asari, Associate Professor of the Kyoto University, and she is a co-lead of the UNEP Minamata, UNEP Global Mercury Assessment Waste Management area. So, Misuzu, the floor is yours. And please limit to 8 minutes in order to have sufficient time for panel discussion.
Thank you very much. Thank you very much.
Mrs. I think you should switch off your video because the line is very bad. So.
In the evening, so I'm a little sleepy, but I'm trying to do the presentation. So please go to the next slide. Okay, next, please. Next, yes. So, expert on waste management, and I'm not only focusing on the Mercury, but also I focusing on all kinds of, especially municipal waste, including food loss or disaster waste or plastic waste. And the one of the target is the domestic hazardous waste, household hazardous waste. So we, especially when I was a student, the university student, I wrote some the papers on mercury waste or material flow of mercury. Next, please. Next, please. Okay. And also, okay, yeah, thank you. So as already mentioned, but I'm the lead of UNEP Global Mercury Partnership. So next, please. So this area, Global Mercury Partnership area, I'm a co-lead of Waste Management area. So this started in 2008, and I become a co-lead, I think 2 years ago. So we have the biggest number of partnerships, and we developed some catalog of our activity, each activity related to waste management, or we are doing some sessions focusing on waste management area. So if you're interested in, please join us. Okay, next, please. Okay, so today I want to introduce one example of mercury and also mercury material flow, mainly done by Ministry of the Environment, Japan. Next, please. Next, please. Okay. So this shows us. So back to slide. Okay. So this shows the mercury emission inventory. I'm sorry, it's not the latest one, but this shows the 2016 table of mercury emission inventory. So you can see the inventory from each sources, and also the total emission inventory was 16 tons per year. So this is reported to the COP, and and also I'm the board member of discussing this table, and we publish every year about this kind of inventory. So next, please. So this will be a part of the mercury material flow. So next, please. So this is the overview of mercury material flow. So you can start from the left-hand side. And mainly we are focusing on domestic production of raw material and in the fields. And then we utilize to each product. Or we can recover from waste processes or waste products, and we will use the domestic mercury demands and manufacturing mercury added products. And on the right hand side, you can see the products used. So then after the product usage, we will sometimes incinerate waste, or we will recovery the mercury from mercury waste. So this kind of flow is the basic concept of mercury material flow. So next, please. But as already Eisaku-san showed, this is a more detailed material mercury flow. I'm sorry, it's very small, but you can imagine what we are calculating. Next, please. So there are several the reason or purposes to developing the material mercury flow. So this is just example, but we list up for the main purposes of developing the material flow. So the first is to get the overall picture of the domestic flow of mercury, and also to identify the areas where mercury management is feasible and required with emphasis, and to identify potentially responsible entities for final disposal of excess mercury, or to review the effectiveness of policy measures. I think the last one is quite important. Next, please. And also another important point is we can utilize to collect data to be reported to COP. Okay, next, please. So I will show several examples about the implementation to the policy. So for example, first, when we focusing on the mercury export, export amount is increased from 22 ton per year in 2010. Next, please. So based on this kind of data, the amount of mercury export greatly exceeds the amount of mercury import. So that means the development of mercury export regulation is essential, considering the impact of export mercury, or reporting is crucial to prevent inappropriate use of mercury in the importing country. So next, please. Or when we're focusing on the domestic mercury demand or manufacturing processes, we can find several trends. So next, please. So more detailed the situation is that. So please see the decrease in the amount of mercury used to produce mercury added products. So the last slide shows the wrap-up figure of mercury demand, but when we're focusing on each product, you can see more detailed trends like this. Okay, so the time is limited, so I will skip several slides. So next, please. Yes, so this is the several example how to implement into the policy from the mercury material flow. Next, please. Okay, and also we need the future refinement on stock of mercury, or the amount of recyclable resources containing mercury generated and disposed. So this is not easy to grasp the situation, but we are trying to refine. Okay, next, please. Yeah, and yeah, the same as before. This is a several example how to implement. Okay, next, please. Yeah, but still, there are several challenges of developing material flow in Japan. So the first is lack of cooperation from the private sector. Yeah, some of the sector it's very difficult approach, but we are trying to find out a good solution. And also there are several uncertainty. So every year we are discussing how to refine this kind of data. Okay, thank you very much. So next, please. Okay, the conclusion is the mercury material flow provides a broad picture of the domestic flow of mercury, and can be an effective tool to implement the policy measures, and requires the cooperation with stakeholders when it is being developed, and should be reviewed to reflect the latest circumstances. Okay, next, please. Yeah, thank you very much. So if you have any questions or discussion, let's discuss later. Thank you very much.
Thank you, Misuzu, for your keeping your presentation very, very brief. Thank you, and very concise but very informative. Thank you very much. And it is a pity that we could not see the video since the connections doesn't seem to be perfect. The next speaker is also from Asia, from China, Dr. Qingru from Tsinghua University, who is specializing in the material flow in the environment and of course in the society. And perhaps if you may turn on the video and try, but if the sound is bad, you may perhaps wish to switch off the video. So Qingru, floor is yours. Please unmute yourself. You are unmuted now. I unmuted you.
Thank you very much. Hello, everybody. I am Qingru Wu from Tsinghua University. My report today is about mercury flow in the western streams of China. Next slide. China is the largest air mercury emitter in the world, but in the past several years, atmospheric mercury emissions have shown a downward trend. This is mainly contributed from the improved air mercury emission control. But the synergy of mercury control have also led to an increase of mercury burden in the West. Next, please. And mercury will be emitted to air or released to water or soil during the disposal of the waste or byproduct from air pollution control devices. Next. So to examine the mercury sources and the fate in China, as well as to examine the flow of mercury flow in and among different sectors, we constructed mercury flow in China. The sectors we have studied has shown in the table. Next, please. This slide shows the methodology of our work. The mercury flow has contained 3 tiers. First one is about mercury input, and the second is about mercury distribution in one certain sector. The third one will be contain the mercury distributed due to among different sectors due to the use of the byproducts or waste. Next, please. And the mercury input is calculated as the byproduct. Excuse me.
Yes. Yes.
Yeah, I can see. I cannot see the slides now. Hi.
This is strange.
Is my problem?
No, I don't think it's your problem. Sorry.
Okay, thank you.
Yeah, I think this is ours. Maybe. Yeah, my colleague Tak Kanan is doing the slide change,
Okay.
but perhaps.
Hi, this is Tak. Eisaku, do you see the screen? Do you see
Yes,
the
I
slide
see
now?
the screen. HG input tier 1, tier 1, tier 2.
Okay.
Qingru, you don't see the slide? HG input tier 1 and
Yeah, it's okay now. Thank you.
Okay.
Okay. So let's continue. So because the Taiwan and Taiwan is not the dominant context of today's report, so I have a brief introduction. The Taiwan is about mercury distribution in one certain sectors, for example, in the coal-fired power plants, and we have set the distribution factors mainly based on the field investigation, field experiments. Next, please. So about the west flow, about mercury flow in the west streams, we need solve 2 questions. First, how were the waste being disposed? The second is how was mercury redistributed during different types of waste disposal process? Next, please. For the first one, about the waste disposal methods in China, the waste can generally be divided into industrial waste, hazardous waste, and municipal waste. It's very difficult for us to have a very detailed information about industry waste because almost of less waste have been classified as general waste, and they are not detailed documented in current environmental systems. Especially some waste, they have some economic benefits. For example, the fly ash, we can have much more detailed information. Other waste, we need to have best questionnaire or experts information. The second one is about, next please. The second is about the hazard waste. China have a national list of the hazard waste, but the problem is we cannot, it's sometimes difficult for us to divide mercury contained waste from other kinds of waste because one waste can simultaneously contain several different heavy elementals. So at this situation, some mercury contained waste may be documented as other kinds of heavy metal waste. So we still need more work to find out how this waste have been disposed. Next, please. The third one is about municipal waste. We have a much more detailed information about the disposal methods about municipal waste. Most of them have been landfilled, but actually, even being landfilled, they can be further being classified as poor landfill site or controlled landfill site or advanced landfill site. In our study, if they are not if the waste are not disposed in the advanced landfill site, we assume that they have been open emptied, and this kind of waste may be released to land. Next, please. The other aspects, we need to understand how mercury was distributed during waste disposal process. We classified the final phase of mercury into 6 categories. The first 3 is about mercury emission or release to the environment directly, and the second is about mercury exports. The exports indicate mercury exported abroad by embodying in mercury-contained products, and the fifth one is about mercury stabilization. If the mercury was stabilized, we believe they have been treated in environmental sound manner. And the final one is Mercury stocks. This stocks happens due to the time lag between use and the production. And we think the embodied mercury will enter production activities and cause potential environmental impacts. The mercury the distribution factors are calculated based on field experiments. Next, please. And then this is an example show how we decided the mercury distribution during different utilization methods of fly ash. And it's just providing an example. Next, please. Finally, we get the mercury flows in China, and we quantified how much of mercury inputted in 2010. And the mercury inputted represented the overall situation of motive mercury in China's anthropogenic activities. And the mercury emission and release accounted for about 52% of total mercury input. The percentage of self-disposed mercury only accounted of 16%, and there's still a larger mercury stocked in the waste or byproducts. Next, please. During the waste disposal process, there are about 16% of mercury released from our mercury flow studies. Such kind of this part of mercury has not been included in our previous inventories. Next, please. And we finally found out the emission sources from the waste reuse, and the recovery of zinc oxides in the zinc smelters and the waste disposal in cement plants are the two dominant secondary mercury emission sources. Next, please. We find that non-ferrous metal smeltings are the dominant sources for mercury release to water and land. It's accounting a very large percentage. Next, please. We also identified the mercury stocks in the waste and the products. For mercury, the waste stored in the mercury recovery campaigns and the zinc smelters can be used as mercury recovery materials. So once the primary mercury mining was stopped, it will be provided the source of mercury in the future, in the short future, in the coming future. In our previous studies, we found that mercury content in this kind of waste is quite high. Sometimes it can reach 1%. And the second highlight, the utilization and the disposal of less waste in the environmental sound manner will reduce potential emission and releases. Next, please. From our studies, we also found out the challenges for mercury waste management in the future in China. First, the information gaps. Currently, there's no information system on the production, transfer, recycle, and disposal of mercury-containing waste. Second, the system of the waste sorting, collection, and the recycling is still in its infancy. The third, current comprehensive utilization of solid waste can reduce mercury releases to land, but lead to mercury emission to air. The final one, limit values for mercury-containing waste are not set. Technical guidelines on mercury waste management in environmental sound manners not set. Next, please. This is the dominant references for this report today. Thank you very much.
Thank you, Qingru, for the very impressive sources of information. And in your last slide, you mentioned the work on mercury waste threshold and guidelines, which we do not talk to today, but there will be a Minamata online session on waste in next month. So I think we can cover that topics then. And also I was impressed. I think I had questions about stabilization because in mercury waste guidelines, stabilization means stabilization as mercury sulfide. But I think we can discuss later. Thank you very much. So
thank you.
Now and thank you for limiting to a very brief presentation. And the next speaker I would like to invite is Gabriela Medina, who is a director of the Basel Stockholm Center, based in Uruguay, hosted by Uruguay, and she's going to speak to some inventories we have in Latin American countries. Gabriela, the floor is yours.
Thank you, Eisaku. Good morning, good afternoon, good evening for everybody. Thank you, the Secretariat, for inviting me. Next slide, please. As Eisaku said, we are a Basel Convention Coordinating Center and Stockholm Convention Regional Center. We next, please. We are in the text of the convention as a Basel Center or Stockholm Centers, and the idea is to do technology transfer for the countries and training and disseminate information. Next, please. We are like a merge for the Ministry of Environment from Uruguay and the Technical Laboratory of Uruguay. So I am the director of the center, and the co-direction is under LATU. That is Alejandra Torre. This is our staff. Next, please. And we are hosted by LATU. So these are part of our facilities, and we have, that is something important to say, that we have a special office to have or to manage all our funds. So it's quite transparent and it's easy to manage our finance. Next, please. Well, as I told before, we are part of the Basel and Stockholm conventions. Under the synergies strategy, we work as well with Rotterdam Convention, and we are going as well under Minamata Convention. As you can see in the text of Minamata, there is a mandate to work with the existing centers. We are involved with all the cluster of chemical and waste. Next, please. We have working on Mercury since 2009. We decided to negotiate a binding convention on Mercury, and now the Minamata Convention. So we start very early to work in the region. Next, please. Some quite important activities that I would like to mention is, for example, we started in 2010 with this project with Costa Rica, Argentina, and Uruguay on minimization and environmentally sound management of mercury containing waste affecting most exposed population in various economical and industrial and health sector. We work basically in hospitals and in the chloralkali sector. Next, please. We work as well in temporary storage and final disposal of mercury and its waste with Argentina and Uruguay. Next, please. We publish a guidance on best industrial practice in the chloralkali sector. Next, please. Next, please. Just the idea is you have some idea of the project that are quite important on the mercury sector that we have managed. This was very important as well. It supports the Minamata Convention and its implementation in Latin America and the Caribbean region. It was a survey on the challenge posed under Minamata Convention and is published in the Minamata website in Spanish and in English. Next, please. Next, please. This is other. We have organized several meetings, for example, pre-COPs or pre-INC meetings. Well, this is some of our work on the field. Next, please. For some pictures of our training or meeting sessions. Next, please. So regarding the inventories in Latin America, we have two kind of projects. We start working on that in 2014, and we finished one of the projects last year on December, one of the projects this year in June. Next, please. So we have, before the MIAS exists like a project under the JEF concept, we were working on the project on mercury inventory, sorry, and risk management since 2014, and the countries involved were Argentina, Ecuador, Peru, and Uruguay. And in Minamata initial assessment since 2014 to December 2019, and the countries involved were Bolivia, Chile, Paraguay, and Dominican Republic. Next, please. So the project and their inventory and risk management plans, as I said, it was like a training on the MIS because we start before MIAS state like a huge whole project under JEF. We saw Argentina, Ecuador, Peru, and Uruguay. The funds was almost 1 million US dollar, and we finished this year in June 2020. We had with the executing agency and the implementing agency was UNEP. The idea was a full inventory of mercury in each participant country, levels 1 and 2, development of national plans for the future monitoring of mercury levels in human beings and in the environment. For example, in Biota and in human beings, we have some hair analysis. And the idea is to study mercury, how can be reduced over the time, and development of action plans for reduction of mercury uses and emissions, including short, medium, and long-term measures. This was the outcome of this project. Next, please. The other, that is Minamata emission assessment. We work with Bolivia, Chile, Paraguay, and the Dominican Republic. Paraguay was the first country in the world to finalize the MIAs. There was a CHEF funds, and the UNE was the implementing agency, and we were the executing agency. We have as well as the project before a full inventory, level 1 and 2, on each participating country. The countries made a comprehensive analysis of the existing legal and institutional framework and have to adapt this framework for an adequate compliance with the obligation under the Minamata Convention. And something was quite important, it was the active participation of all stakeholders through a coordination mechanism that led to the project activities. Next, please. Well, here is the outcome of the project as a whole. We are going to talk the two projects as one. We have a publication on that is available in English in our website, and we can share with you. And we find that, for example, in the case of the countries that have artisanal gold mining, the major emission source were that. And this is what's happening in Bolivia, Ecuador, and Peru. I hope you can see, because it's quite small, maybe the letters, but the major amount of emissions came from the artisanal small-scale gold mining. The same happened, next please. In Ecuador, you can see as well is the clear blue one, and the same happened in Peru as well. Next, please. In Peru is huge. The amount of mercury that came from the artisanal small-scale gold mining. The data are for 2014, where they use the data for the toolkit for the inventory. And Peru they apply a different two scenarios. They put in a minimal situation and in a maximum situation. So this is the number that we can find, but it's huge, the amount of mercury emissions from these sectors. Next, please. In the case of Argentina and Chile, they have primary metal production, mainly gold extraction. So this is the major source of mercury. The measures is without mercury use, of course, but even the raw materials of the mining, they have like a subproduct mercury. So This is what we have found. Next, please. This is the case of Argentina, and the Chile is quite similar as well. Next, please. In the case of Uruguay, my country, well, we are quite small. We don't have any kind of mining. We have a small gold mining, but without mercury as a subproduct. And in our case, the emissions, the major source from the industry. During this project, we found that we identified a chlor-alkali plant in Argentina, one in Uruguay, and 2 in Peru. In the case of Uruguay and Argentina, they tried to change to a mercury-free method by the year 2020, but we are suffering from this pandemic situation, so all the processes have been delayed. And in the case of Peru, they compromised to change the technology in 2030.
Gabriela, can you speed up a little bit?
Yeah. In the case of Dominican Republic, the huge amount of the mercury emissions came from waste disposal and wastewater treatment. You can see it is huge. Consider others. They have a very bad management on waste. So this is what happened. They don't have mining, whatever. So this is what we found. Next, please. In the case of Paraguay, the mismanagement of other mercury products, there is waste incineration and emission for the life cycle products. So this is what we found. So the main issue are the industry. In the case of chlor-alkali plants using mercury electrodes, and in the case of countries with artisanal gold mining, this is the issue. And in the case of the countries that don't have this kind of issue, the waste are the main issue. Next, please. That is something important to remark, that the project made possible to establish an interministerial and intersectoral dialogue on each country, on mercury and its effects. So it was a very important awareness raising. At the beginning of the project, the toolkit was translated into Spanish. So we have the toolkit translated into Spanish as well. All the inventories were reviewed by the UNITAR and they were updated to the last version of the toolkit. The data were used for the global mercury assessment in 2018. And it was quite important that with the funds, we can have several trainings, for example, on how to remediate a site. That it was carried in CMAT in Madrid in Spain, and we have 2 kind of training on analytical service in different matrices and even in speciation in Slovenia. Next, please. We have as well mercury passive air monitoring for 5 weeks that were analyzed in the Consiglio Nazionale delle Ricerche in Roma. And we have a training on intercomparison laboratory exercise made by Resetok, Pleased and Brno, Czech Republic. And in some countries, the registration of certain data was established. So in the future, it was very easy to to update the inventory. Next, please. I think it's the last some pictures of the training, and that's all. Thank you for my side. Thank you.
Thank you very, Gabriela, for your very comprehensive presentation. And with regard to the Minamata initial assessments, we in the Secretariat, we make the submitted reports on the website, but so far we have only received reports from Bolivia, Dominican Republic, and Paraguay. So we very much look forward to receiving reports on others. And if not submitted, perhaps we can. It would be very helpful if we can have a look at these inventories. So having said this, I'd like to invite Alexander Romanov, a friend in Russia. He's deputy director of the, or director, I forgot, Scientific Research Institute for Atmospheric Air Protection, but we invited him because he did a study, the comprehensive study on the mercury pollution in Russia. So I give it the floor to you, Alexander.
Thank you, Eisaku. Can you hear me clearly?
Yes, I can hear
Perfect.
you.
Perfect. Thank you very much. So, good morning, good afternoon, good evening, colleagues. Thank you to the Secretariat for inviting me to provide this talk. I'll try to be brief. I know that the 8-minute policy still applies. So basically, as you know, the Russian Federation is the largest country in the world. So with the not so dense population, we still have a lot of historical and other types of geological as well mercury issues in some places, and not so many in others. So the first attempt to actually try and assess how much mercury is there in the environment, and what are the sources of that, were taken in late 90s, early 2000s. Back then, the discussion was mainly going under the Arctic Council and its Arctic Contaminants Action Program, so-called ACAP. So basically, the idea was born there to actually try and assess mercury releases under the Arctic umbrella. And I'll show you some outputs and outcomes of those assessments today. And later on, based on those outcomes and under the discussion of back then still not the Minamata Convention, but under the INC, so Intergovernmental Negotiation Committee, there was a project on assessment of mercury emissions from coal-fired power plants in Russia. And then again, as a predecessor of the MIAs, we implemented UNEP Jeff-supported pilot project to develop the mercury inventory in the Russian Federation. And that was the largest attempt to date to assess mercury releases in all sorts of media. So the next, please. Yeah, so basically the latest attempt was based on the famous UNEP Mercury Toolkit, and we tried and we did use actually some nationally developed release factors, not as many as we would like to or we wanted to, but we tried to our best to actually apply the best knowledge domestically available back then. And the reference here for the study was 2012, as the whole study was performed mainly in 2013, 2015. So basically, the most complete data sets were available back then for 2012. and we believe that since then not much has changed in that respect. So whatever errors, whatever margins of uncertainty we faced back then still remain now, and the numbers are still as reliable as the errors and uncertainties are. So the next one, please. So from here you can see the summary table of the inventory, and I mean, this table basically covers all media, and it could be used for other sessions. But as well as long as we are talking about waste and kind of cycle today, I would point your attention at that particular graph and column. And generally, I would say that what we found out that land and waste streams are mostly affected by mercury in the Russian case. We received some heavy criticism from our domestic experts on the estimates, mainly for land, which is not exactly and which maybe not exactly the case we are talking about today, but anyway, the numbers are mainly for waste and land, and the rest, so basically water and air, are relatively small in comparison to those two. Anyway, so the total assessed amount of mercury being released is some 1,000, almost 500 tons, and more than almost 90% comes from the primary virgin metal production, and most of that goes to waste and land. Please, the next one. Yes, again, this is pictures, just visualization of the table we just looked at. Here it's probably more clear and important to say that how much uncertainty is there in this land piece of that pie. We generally used the geological data and some data which was derived from reports by key mining companies on mercury content and how much they actually deposit in the tailings and in the spent raw material. How much mercury statistically is there, and how much of that is mobilized, and how much is just being there in the spent material is still the subject to further clarification and further studies. And as I mentioned already, our geological friends and geological colleagues criticized us on the fact how much we actually put on that spent material in those tailings in terms of mercury. And we reiterate basically that it's not active liquid mercury. However, the mining in Russia has been done in massive scales, so potentially amount of mercury can be as massive as well. Next one, please. Yeah, so here just another way of showing that how much the sector of actual metal production, and this is non-ferrous metallurgy, basically flies over all other sources, and we do have some consumer products, the whole life cycle, as the methodology defines it, but still, I mean, the bulk of whole waste disposal comes from the primary metal mining, metal production. The next one, please. Here, this is what how much special treatment basically, and how much recovery of mercury actually can happen, and how much can be trapped. So here you can see in the energy sector, up to 8 tons of mercury is estimated to be specifically treated or kind of trapped and then disposed of. Again, the methodology is, of course, the key, the leader. And here it's important to also mention that we still have 3 chloralkali plants in Russia that do use metal mercury for their processes. So the membrane of this old technology is still existing and being used. And what we've seen, it seems that one of the limitation towards ratification of the Minamata Convention for the Russian Federation now is that those 3 factories see great difficulties in raising enough financial resources to actually convert, and also they basically want to stay in operation with the old technology as long as possible, which is of course unfortunate. The next one, please. So basically, I wanted to also to point out the findings we from the first study, which is now almost 20 years ago, and here you can see that the most precise estimates for like intentional mercury use is like 43 tons, and uncertainties are quite low in this particular case. Chloralkali is the leader, as I mentioned. And it seems that the latest estimates are a little bit closer to reality, because back then those numbers were taken only from the reporting, and then later on that reporting was adjusted several times. So the losses in chloralkali seem to be more than reported initially. So the next one, please. In terms of the mercury mobilization from impurities and from raw material, here the zinc production and copper production are the leaders 20 years ago, and since then we've also recalculated that and saw that copper and nickel seem to be much cleaner than it was perceived back then, but zinc is much more mercury intensive. And we almost did enter the largest zinc plant in Russia and among the 3 largest in the whole world during that study, but at the last minute the whole plan was cancelled. Anyway, the next slide, please. Yes, and then for waste processing, again from those sectors, you can see this is the most accurate analysis of the consumer products with the mercury in those that still exists. So during our study, the recent one, it was next to impossible to get any closer even to those numbers. So the reporting is very much relaxed and merely existing at all on mercury in those types of products, and whatever producers are there, they didn't really have any will to share information. But anyway, the cumulative total you can see in this table actually sums up everything, all sectors I showed you, and so this is only 95 tons estimated per year. And as I mentioned in the slides from the recent study, those numbers are completely different scale. So the next one, please. The recent results were presented at the ICMGP Zone 17, and they're published and they're available. And for whatever questions there might be towards the authors, please don't hesitate to contact me or my colleagues. So with that, thank you very much again for your time. And yes, and then you can see those links to the reports, both in Russian and in English. And those English, at least the English report is also available in the knowledge storage of UNEP on Mercury. And I guess Eisaku, his colleague, can share the link to all the reports or you may already know where those are from the MIAs and related projects. Thank you very much.
Thank you, Alexander. And I think it is very interesting to know that there are quite a criticism about the estimates from the mining metals sector, which connects very well to the next speaker, who is Melissa Barbanell, who is going to speak on behalf of the International Council on Mining and Metals. So, Melissa, the floor is yours.
Good morning, good afternoon, good evening, everybody. If we could go to the next slide. Thank you for the opportunity to speak today. Just by way of background, I've been involved in the development of the convention, and I served as one of the experts on the air emissions technical expert group, and I'm currently an observer in the waste and releases group. ICMM, for your background, is a CEO-led association whose membership includes 27 of the largest industrial mining and metals companies operating in over 50 countries and over 35 national, regional, and commodity associations. Its focus, the organization's focus, is on safe, fair, and sustainable mining and metals production. In 2009, ICMM members adopted a Mercury risk management position statement. The members committed to apply material stewardship to promote responsible management of mercury produced at operations, as well as to minimize air emissions. It also recognized that the mercury supply from ICMM members' operations would be reduced and eliminated when policy and economically viable long-term technological solutions for the retirement of mercury existed. We are certainly moving in that direction. ICMM members' operations are subject to strict regulations and environmental management measures. Can we go to the next slide, please? So we're seeing on everybody's slides the enormity of the mercury waste associated with mining and metals production. So I wanted to really start by saying why are we seeing this? And I think that it's critical to understand that mercury is a naturally occurring impurity that is found in some non-ferrous metals ores and in the waste rock that exists around them. Typically, that amount of mercury exists at very low concentrations. It can be variable depending on the local geochemistry. So my slides really focus on metal production, but I just want to take a minute to explain that we start with the rock, and a significant portion of that material, waste rock and overburden, gets placed into engineered, permitted, on-site storage. And a lot of what you're seeing, I think, in everybody's slides today reflects that. And the numbers that are used in the analysis reflect the massive quantity of rock, which is non-ore bearing rock, which is removed in order to access the ores. So I just wanted to kind of start there. Once we get to the ores, we've removed the waste rock and the overburden. The ore goes through many steps to be transformed into metals. The process varies depending on the characteristics of the ore body and the metal being produced. The mercury follows the concentrates through the process. So what this means is that as the processing happens and there's gas cleaning at every step of the way, you are removing mercury. There's an opportunity to clean the airstream and to remove the mercury. When the mercury is recovered and removed from the gas cleaning, you can find it either as elemental mercury, calomel, or carbon contaminated with mercury. As air pollution control efficiency improves, you will see higher levels of mercury waste. Next slide, please. So this slide speaks to gold. Gold and zinc are the only two slides that I have that are specific to metals, but they are only 2 of the 4 that were identified, or sorry, 6 that were identified in the 2017 UNEP report on global mercury supply, trade, and demand. The process is very similar for most metals, so they're indicative of what happens. The flow sheet to the right, you see it starts with gold ore or gold concentrate, so it doesn't even talk about the waste rock that I just sort of described to you, which is where a significant portion of the waste that you're seeing described in other people's presentations is coming from. Again, that waste rock, that overburden is going into engineered, permitted facilities that do not necessarily mean, that should never be releasing to the environment. But in any event, gold is extracted from the ore via cyanide leaching. Prior to leaching, the ores may require milling, flotation, or pretreatment. The pretreatment would either be roasters or autoclaves. And again, most mercury typically follows the gold concentrates. When you move into the refining side, the mercury is recovered from the gas stream throughout the process. At the roasters, it's removed through a Boliden Norzing scrubber, and it becomes calomel. Electrowinning has gas cleaning. Carbon regeneration kilns have gas cleaning. And the retorts produce elemental mercury. Again, this is the sludge that would be going into the furnace, goes through one last step to remove any existing mercury. So you see in the slide to the right, you see where you have elemental and carbon contaminated mercury in some places and calomel coming from the gas cleaning from the roaster. Next slide, please. So similarly for zinc, zinc deposits are milled and separated from the gangues by sulfide flotation. Again, the mercury typically follows the zinc concentrate. Most of the mercury is recovered from the gas stream from the roaster. And again, like in gold, they use a Boliden Norzing scrubber, so you wind up with calomel. Mercury is also captured in the sulfuric acid plant so that the acid can meet the quality specs for sale. Mercury there is often captured on carbon filters. So you'll see those 2 waste streams coming off of the zinc processing. Next slide, please. So this slide really speaks to byproduct and what once was byproduct. What you're seeing and what you'll notice in that mercury position statement from 2009 is we talk about the retirement of mercury. So byproduct, you can have either elemental mercury or calomel. And what you're seeing is that there's not really an opportunity for commercialization. You have export bans occurring in more and more countries. You have no internal legitimate market. And you're seeing that plants are not selling their mercury anymore. So that byproduct mercury, calomel or elemental mercury, is now a waste. And, a survey of zinc plants indicates that neither mercury nor calomel is being sold. With regard to gold, what I do know for sure is that the 2 largest gold mining companies in the world, Barrick and Newmont, do not sell their byproduct. When it comes to disposal of elemental mercury and calomel, disposal happens according to location-specific environmental regulations. It sometimes can occur as a final disposal option in permitted hazardous waste facilities. For instance, we see that in Germany and in Quebec, in both places where it is stabilized and then stored either underground in salt mines or in concrete bunkers. The other option that we see is long-term storage of the byproduct mercury, which takes place at many third-party sites, or it can happen on-site at the mines. Among the considerations that have to be put in place for long-term storage and disposal is the cost and the security of the material that's being stored. Next slide, please. So our conclusions, is that companies are increasingly treating byproduct mercury as waste, and they're managing it by using long-term secure storage or by permitted disposal facilities. Increasing regulatory pressures and improving availability of mercury alternatives are effectively reducing the legitimate demand for mercury, and you're seeing that it's not being sold. Mercury waste from the mining and metal sector can consist of mercury contaminated waste, like we talked about, which would be category C waste under the convention, recovered elemental mercury or calomel. In many countries, the mercury wastes are reported via PRTRs or other registries for elemental mercury and or calomel. Next slide, please. So just final thoughts on this. As supply has been dwindling and elemental mercury prices have gone up, we think it's really critical that authorities remain vigilant when it comes to the illegal trade of mercury. We heard a couple of weeks ago at Minamata Online how problematic this is. Also, and I think this is really critical, as metal demands are forecasted to grow in support of the long-term low-carbon economy, and because mercury is a naturally occurring impurity in the ores, the mining and metal sector is likely to continue to produce mercury waste. It's important to understand that every gram of mercury that becomes a waste is not emitted as mercury air emissions. That's the whole point here, is it's conservation of matter. You can't get rid of the stuff. So you either emit it up the stack or you capture it and control it as a waste. We recommend that effective and sustainable regional solutions to secure sufficient capacity for the safe and long-term storage of mercury take place. So having more options for disposal around the world would really be helpful. Right now, we have companies that are shipping elemental mercury from South America to Germany, which is not ideal. So that's all I have. Thank you very much for your attention, and I'm happy to take any questions.
Thank you, Melissa. So now we have 10 minutes for this panel discussion. I think we can only do a first one round of questions, or even less. I think earlier I invited questions in the Q&A box. I see none, and I noticed that if you put questions, you can select who you address that questions, and if you have typed in any question to set a specific speaker, I cannot see. So I'm not sure whether other panelists are seeing. You can put your questions to all panelists so that we can see. So having said this, I think we will keep an eye on the chat box as well. So I very much appreciate all the presentations, and have taken the opportunity of Melissa's presentation. I think I can start with the mining issues. And since we heard that there's some challenges in Russia to precisely quantify the mercury in mining waste stream. So I think I have two questions. In terms of mining waste, which in the Minamata Convention is defined as waste rock overburden and tailings, and now the group is working on the mercury content threshold tailings. So do you think that we should draw a system boundary between waste rock and overburden and tailing, and we should quantify the mercury in tailings, or isn't the situation not that simple? And my second question is, if so, do you have any good suggestion to how to quantify the mercury flow in mining waste stream? Melissa, do you have any?
Not an easy question, Eisaku. I think that all of the three types of sources that you're talking about, or facilities, are all engineered and managed facilities. We've seen in the United States, and I know you have expertise within UNEP that has the experience from the United States about how mercury is reported in terms of the quantity that it sort of is described as in our waste rock and tailings ponds. And the numbers, I mean, in my opinion, the numbers are misleading. It makes it seem as though everything that's moved to waste rock is, counts as mercury, and it's not the case. And I think that it's a structural problem, and we have spoken, with Jakob about this in terms of the toolkit. I think it's a real challenge. I mean, I don't think there's an easy answer. I do think that it's something that merits more focus and discussion in terms of how should we be quantifying these wastes, because I don't think it's as straightforward as the simple mass balance that we're seeing. And I do just think that my sense is that we're attributing a whole bunch of material that's not mercury, but that contains mercury as it. So that's my worry, if you will.
Thank you. I think we will need to look at the figures, numbers in statistics in material flow studies in many countries. And so then I would like to turn to Misuzu, I think, because and also Qingru about. I'm not limiting the discussion to mining waste, but is what do you see the challenges in keeping a kind of continuous picture of the the material flow, of course, including mining waste, but not only limited to it. So may I turn to Qingru to on that question?
According to our previous studies, I think one of the largest challenge to build the mercury flow in the Western Stream is that we should obtain a lot of information about the waste disposal process. We need to know how many waste was disposed in one certain process, because we know different disposal process will lead to different mercury fate finally, and and especially for the industry waste, because the industry waste in China were generally regarded as the general waste, and most of them have not the economic benefit, so we cannot to get the information directly from the statist or from the yearbook. So we need to have a lot of investigation or make questionnaire.
Thank you.
Yeah.
That's very helpful. Misuzu, do you have any other message?
Thank you very much. So, as I mentioned, we have several challenges. So the one is the lack of cooperation from the private sectors, not mining, but several sector. It's quite difficult to get many information. But that kind of communication is, I feel, quite important. So we have the kind of board meeting to polish the material flow. So during that process, we have several meetings with private sectors. So we can know each other what is happening or what is the solution. So the developing or polish the material flow itself is quite important communication tool, I feel.
Eisaku, I think you're muted.
Sorry. I was muted. So thank you for the insight. And my last question would be about that exact challenge to Alex and Gabriela. I think in Alex's table, for example, the emissions the emission releases from oil and gas industry was kind of a question mark. So including these sectors, what do you think is needed for a more exact picture on of the mercury flow in Russia, and what are the plans? And also I'd like to ask Gabriela about whether these countries are going to update these inventories of emission releases and waste flows. Alex, please.
Thank you, Saku. What we've seen, I mean, when we talk to our geologists, they said basically that in the second half of 80s, there were several studies on mercury in key energy resources type of things. So basically in oil and gas and different types of coal. And as the numbers were highly variable on the one hand, and then back then the technology was not yet that precise as we have now. So back then there was we had an atlas or like a catalog of those numbers, and we actually used some of those numbers for the inventory. One thing is with us is that a lot of natural gas that is produced in Russia is being exported directly through pipelines. Same goes for crude oil. So in that respect, it's an interesting case, because what we've heard from some companies that actually do export that natural gas, for example, that they face the problem of mercury being condensed, and then liquid mercury kind of, actually damaging those pipelines in the pumping stations in those centers to that keep the pressure in the pipeline. And then they basically, from time to time, maintain those pumping stations and release that mercury, that liquid mercury that being condensed. How much of that mercury is actually being there is a big thing, is a big question. There is no state regulation that would require those companies to actually measure that or monitor that. On the other hand, we exported gas to Europe, for example, and where supposedly it should be controlled in terms of mercury as well as some other organics and some other heavy metals. And there was, as we couldn't find any case where any concern in that respect would rose, either from the producer side or from the consumer side, both for natural gas and oil. So it seems that there is some research interest, and we do have it, and there is a reason for that, but there is very low interest from the producer side, of course. And the historical data says that what we have in Russia is quite mercury low for all three, for coal, for gas, for oil. At the same time, when we're speaking about the amounts being extracted and moved around, then that's where it comes the whole discussion. We wouldn't be. I mean, Russia was one of those who supported. I think it was Iraq back then, and someone else, Saudi Arabia, to exclude oil and gas sector from Minamata during the INC. Back then, no one knew that it would be called Minamata Convention, and it's clear that there is a concern, and we've seen cases in Indonesia and some other places where this particular sector can be a problem. But I mean, it would be interesting to research, of course, to do research on that. How it can be done, that's another question. Eisaku, you are muted. I can hear you.
Sorry. Okay. So although it is 4 minutes past the closing time, I would really like to invite Gabriela to address my question about the challenges and prospects for inventories in Latin American countries.
Thank you, Eisaku. Yes, in GRULAC, in the whole GRULAC. So not just in Latin America, but as well in Mesoamerica and the Caribbean as well. It's a challenge to have this inventory updated because well, we have different needs as from developed countries, and so it's not easy to update the inventories because we have, for example, during the execution of this project, we have a lot of change of governments, change of people involved. So sometimes it's not easy for the government to give money for the data and inventory. It's not an obligation for example, under the Minamata Convention. Another issue is the huge amount of the emissions from rural countries, from Latin America and the Caribbean region, came from the uninformed sector. That is the small gold mining, artisanal small gold mining. So the informal sector is an issue as well per se, because sometimes it's not easy to manage this sector, and when the prices like we are living now because of the COVID prices, the informal sector is the more affected, of course. So it's not easy to I don't know, think a long term or a process to work in this sector in a crisis like that we are going to like we did, I don't know, for the maybe 5 years coming. So I think it's a huge challenge to have the updated inventories. We need to know about the trade or the flow in South America. South America is one of the more major sources of mercury in the world. So I think we need maybe the convention help to do that. So this is my answer. Thank you.
Thank you, Gabriela. Now it is 7 minutes past, so I think we need to stop. I see many good questions in the Q&A box and the chat box. For the last time, we reviewed all the questions and tried to respond to these questions in the final the summary of the report. So. We need to close this session now, but we will keep this WebEx session 5 minutes before the closing so that anyone can, with a question, can type in their questions in the Q&A box during that time. So with that, I really need to close this session now. Sincere thanks to all the panelists. I think this is a extremely fruitful session, and thank you all to all the participants. We very much would like to follow up on this conversation. If any of you are interested, please. And if any of you have good information about any national level or regional level material flow study or waste flow analysis, please let us know so that we can consider that. And also, of course, warm thanks to our colleagues, Sandra, Tak, and Dean, who helped this session to happen. Thank you very much. Stay safe. Have a good day. Good weekend. It's a bit too early. So anyway, thank you very much.